Hi, for this video what I want to do is I want to show you how to find the equation of a polynomial when you are given the graph. And for this we do want to find the least degree polynomial that we can have. It's because of the fact that some polynomials with different degrees can give you the exact same graph depending upon the multiplicity of the points or the zeros. So we want to use the lowest multiplicity that we can possibly have. Okay, so let's talk about some things on this graph that will help us identify what kind of polynomial equation we have, whether it will be an even degree polynomial or an odd degree polynomial. Okay, so we can see that for this one that it goes up from left to right. So since our endpoints end in different directions, whenever this happens, this tells us that we are going to have an odd degree polynomial. Okay, so it's going to be degree 3 or degree 5 or degree 7. Okay, we also know that our leading term or the leading coefficient is just the fancy name for the number in front of our x squared or x cubed, our highest variable term. Our leading coefficient is going to be positive because of the fact that it goes up from left to right. If it went down from left to right, then the leading coefficient would be negative. Okay, as far as the least degree, we can find that by looking at our turning points. So this one has 2 turning points. And so since we have 2 turning points, remember that n minus 1 equals the turning points, that the maximum number of turning points that a graph can have. So since we know that n minus 1 equals 2, if I solved this for n, that tells us that this is going to be a degree 3 polynomial. So our least degree that we can have is degree 3. And since we have exactly 3 zeros that are given to us, that means that each of those are only going to repeat once. And remember that one thing that you can look at is that at any of these points, if they touch the graph, then it has to have an even multiplicity. But all of our zeros, they cross the graph, or they cross, sorry, not the graph, the x-axis. And since it crosses the x-axis, that tells us that we have to have odd multiplicity. And the lowest odd number that we can have is 1, so that will help us to determine our exponent that goes on each of our factors. Okay, so if we look at this, we know that the zeros that we have are x equals -1, x equals 0, and x equals -2. So working backwards from solving an equation, remember that when we solve a polynomial equation, this is our final step. Well, what we are going to do is we're going to first start with, okay, what were our factors that we solved in order to get these answers? Okay, so our first one would be x plus 1. This one would just give us x, and if you want to put it in front, that's fine. And then this one would give us x minus 2. Okay, so then what we are missing is we are missing our leading coefficient, and so we're going to call that a. Okay, so we've got to find a, and what we are going to do to find a is we are going to use the point that they gave to us. So they gave us that this point right here is 1, -4, and so we're going to use this to find a. And all we're going to do is we're going to replace x with 1, and we're going to replace f of x with -4. So we know that when x is 1, our output is -4, so we have the equation -4, a times 1 plus 1 times 1 times 1 minus 2. And so now we can just simplify this equation, and that will help us find our a term, which will give us our factored form of our equation. Okay, so if we simplify this, we would just have a 1 plus 1 gives me 2 times 1 times -1, which ends up giving me -2 if I simplify. So my a term ends up being +2. If I divide -4 by -2, I end up with +2. So now we have an acceptable form of our polynomial equation. So we can say that f of x equals 2 times x plus 1 times x minus 2. So this is a completely acceptable form of the equation, and this is known as the factored form. So sometimes you are going to be allowed to just leave it in factored form, and other times you are going to be asked to put it in standard form. So if you have to put it in standard form, all that means is we're just going to expand the equation by multiplying out all of our information. I'm going to go ahead and write the 2 and the x in front first, and then I'm going to multiply my binomials together, the x plus 1 and the x minus 2. Okay, so if I distribute this out, we would end up with x squared minus 2x, and then if we multiply on the inside, we would end up with plus x minus 2. And if you can simplify that in your head, you're more than welcome to do that. I always just try to show out all the steps as I'm going through so as not to confuse anybody. Okay, I'm going to keep the 2x on the outside, and I'm going to add my like terms. So I would have x squared minus x minus 2. And then my final step, we're almost done, is to distribute the 2x into here, and we end up with f of x equals 2x to the third power minus 2x squared minus 4x. And you can always plug both of these into a graphing calculator or into a program like Desmos, where you can graph the information, and then you can check to make sure that you didn't make any mistakes when you were expanding it out. So if both of these end up lining up, then that would give you, then you know you did your work correct. Okay, so this would be known as standard form. So just to recap, when you are given the graph, you always want to identify where does it cross the x-axis. You also want to identify a point that your graph goes through. Remember that if your ends go up from left to right, then you would have an odd degree. If both of them go in the same direction, then you would have an even degree. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like me to cover, please let me know that as well.